Hey there YouTubers, how's it going? Welcome back to the channel. Hopefully you enjoyed the last video, and if you did, hit the subscribe button. Could definitely use a lot more feedback, and hopefully things like this will be interesting to you in terms of software development. So one of the things I want to talk about in this video is the whole idea of serverless. So this is a term that's kind of had a lot of hype in the last couple of years. Quite useful for some have found it useful, some have expressed like concerns with the whole idea of serverless. Is it just a buzzword? Is it something new? Is it, is it necessarily helpful? With this video, I'm going to talk about my experience with serverless. Is it useful? Can it benefit you? Some of the introduction into serverless, and hopefully you will leave this video with your own idea of getting into that as well. So please let me know in the comments below, how have you found serverless and your experiences too. So I guess for some of you that may not be too familiar with the idea of a serverless, I'm going to sort of intro that a little bit. And to do that, it's easy to explain that by contrasting it with the typical architecture for an application. Well, as I'm sure some of you may be familiar with, this is usually what you might see or what you might be working with when you're building an application front to back. So you'll have some kind of front end, whether it's a mobile app, whether it's a website. That's going to be your main user interface, and it's going to be effectively handling some of the user interaction and sending these requests to a backend server of some sort. So with your backend server, you might be using Java, you might be using nodejs, it might be hosted in a Spring Boot application using Express. Whatever it is, you're typically going to be having this backend server that's going to be running, waiting for these requests, servicing them, and issuing a response to the front end. And that server could be talking to a database to get some information that needs to be displayed back as well. So this is that typical front end, back end database split, which is, this is a super common example, super simple architecture example. Now looking at this is kind of an idea of how serverless handles that same situation. So instead of having a single backend server, or maybe multiple backend servers if you're using microservices to kind of split things by what they need to do, you're going to have the idea of serverless, which is effectively functions as a service. So each function is its own service that's going to handle that particular request. You've created some code or written some code that's going to handle that specific request. Maybe it's retrieving some bank account information once you've clicked a screen to show bank account. Maybe it's to view flights when you're trying to search in something like flight search application. That function is going to handle something specific, and it may make use of the database, and it's going to serve that up to the front end. And with this idea of functions as a service, that function is basically going to be spun up in a container. That container is going to handle that request and receive, and handle that response back to the front end. And then effectively that container will eventually, be spun down and not available for that particular piece of work. So really, your container is going to be handling that only as and when it's needed, and it's not going to be necessarily running all the time, as opposed to the typical backend server where it's going to be constantly running, waiting for requests and issuing a response. So this is kind of what you have in terms of serverless, split between multiple functions. They could be using multiple databases, and this is kind of the serverless architecture for handling that specific case. What's important to mention is it doesn't have to be using serverless. It doesn't have to be a REST API, or it doesn't have to be something that handles requests, in this kind of synchronous nature. It could always be a batch process running in the background. Serverless can be used to handle that. Things that maybe need to be done on a scheduled basis. There's ways to do that using serverless as well. But this is kind of the most common example of how it really interacts with, you know, the most useful situation. So although the name is serverless, there is in fact servers behind the scenes. It's not sort of just running on thin air or magic or whatever. There is going to be some servers behind the scenes that's actually going to be doing this work. The main thing here is with serverless, you kind of don't care too much about the infrastructure in the background, and you're not really taking into account anything about the number of instances you might typically need to run if it was, you know, a standard sort of REST service. You just really are just building the functions, and they get invoked as much as necessary based on the volume of requests you've got coming in. So it can be simpler in that sense, where you don't really care too much about how much provisions you need to make to handle a certain amount of requests coming in. The containers get spun up, they handle and do that piece of work, they get spun down, and effectively for you as a developer, especially if you don't really care too much about infrastructure or anything like that, this can be a quite simple way to build applications and to build functions. So why has serverless gained so much traction in the last couple of years? Well, to explain that, I guess we have to kind of go into the benefits of serverless. As I've just mentioned, the whole idea of not having to worry too much about the number of instances I need if there's a high volume of users or requests coming in. It's quite simple to just think about your function that needs to be invoked, and that's it. I will get into a little bit more of why that might not just be the case, but effectively that's what serverless is trying to give you the ability to do, not have to manage too much about the infrastructure and deal with how much volume you might need to necessarily take care of. One of the other main reasons serverless has kind of benefited a lot of people is in terms of actually getting something up and running quite quickly. This is an example of the very small amounts of steps needed to actually get your serverless function created, in terms of at least the setup anyway. So really you just need npm or yarn, installing serverless, creating one of the many templates that are available. The templates there can be found on the serverless website, but those templates can be, depending on your language of choice, directly creating your service, whether it's Java, whether it's Node.js, whether it's using TypeScript, using Kotlin. There's a lot of these templates that already exist to get you off the ground running quite quickly, so that you just fill in the code that's necessary. And then you just deploy to your serverless cloud provider of choice. I've used specifically AWS. You can also use Google Cloud Provider, and there's a lot of other services, cloud providers out there that's going to allow you to develop a serverless application that you can deploy quite easily. And typically, once your function is deployed, it will be served by your API gateway. In the case of Amazon, you will have a URL there specifically for you that you can invoke and sort of test that your function is working correctly and giving the response that is necessary. So it's quite a very easy setup, and there's not too much involved to get started. So after running the serverless create in a terminal myself, using the template AWS Node.js TypeScript, this is kind of what I've got with the project created, the default project created. So some things that are important here, there is a file called serverless.ts, which actually handles most of the configuration behind your serverless functions. So this actually has the name or the overall name of the service. Here, my new service, framework version, something such as the webpack config, which has automatically been generated. If you're kind of happy with that, the standard webpack configuration, you don't really have to do anything there. Some plugins, and you can add additional plugins depending on what you need done. This is kind of fine for the very standard basic setup. Also, what's mentioned here is what the actual cloud provider is. AWS by default. That's generated there because of the template I use, but there's obviously other cloud providers, as mentioned before, you can use instead. And this is the specific runtime functions, which is Node.js version 12. And the real thing of importance here is the actual functions, which is where you're going to be adding the various REST API endpoints that you have. The default that's been given here is a simple one under the path hello, which is a GET request. And then we have the point or the handler, which is actually going to be invoking the code, and that's where we're going to be doing our generation of what that response is going to look like, and handling the actual request that comes from the front end or the user when they call this hello endpoint. So here it's under handler, which is going to be the name of the file, and there's going to be a method in there called hello. I can see in the left hand side there's a file called handler.ts, has my function hello, and by default this is kind of just returning a very basic body which has a message and an input, and that message is sort of hard coded there. So at this point is where you as a developer are going to fill in what you need done, whether it needs to connect to a database, whether it needs to do something with the input that the user might have provided. It's kind of completely up to you, but that's the very bog standard setup. And as mentioned before, you can create your template in your language of choice. I've used TypeScript here, but it can always be set up with Java on the back end, Python, Go. There's quite a few languages and a few templates that are there that you can actually use to set up your serverless functions. Now that's just the basic introduction of generating a serverless function. I will be going into detail on that in a future video where I'll be actually doing an example of how to build everything from scratch, test your endpoint, have a front end and back end completely running using serverless technology, as well as sort of your front end of choice. Other, I guess, really big benefit of serverless is typically the quite low running costs as well. So thinking back about what I've mentioned with serverless, your container is going to be spun up just to serve your requests, and it's effectively not going to be running if there's not a request coming in at that particular time. So that does mean that when you're thinking of your AWS cost that you have to pay, that is reflected in the container not running all the time, because it's only running when it's serving your requests. All of the times when it's not running, you don't have to pay for that. So it's quite cost effective, particularly if you are, just starting out building an application or building a service, and maybe you don't yet have that volume of users coming in. Well, at that point, you don't really have to pay that much because there's not going to be that many requests. So really, you can keep your costs low, particularly if you're starting out. And even once you start receiving a fair amount of requests come in, the actual AWS Lambda costs are still fairly low. So for about 1 million requests, and given you're using the free tier, this is actually working out to something like $1.67 a month for those 1 million requests. Once you have the free tier kind of gone after a year, that does raise to about $8.50, but that's still quite low for like 1 million requests. So it's quite beneficial, particularly in a point of view of building an application just to kind of get your feet wet and deploy something without having to have a large amount of cost potentially coming in. As also mentioned previously, another big benefit is not having to worry too much about this whole idea of infrastructure. It really is the main basis of serverless. So particularly once you do start having a large amounts of volumes of requests come in, then keeping track of how many instances you need is something that you don't have to worry about. But that now leads me into the next point of some of the disadvantages for serverless. So one of the major downsides for using serverless to build your backend is the whole idea of cold start. So this is something that's also mentioned sort of hand in hand with people that are working and have built serverless applications. The main reason because of that is, as mentioned, the container does need to spin up to run your application. When we think of how a typical request is handled with serverless architecture, it kind of is something like this. So what we see here, the whole idea is that the code needs to be retrieved from storage. With AWS, that's going to be, your code is actually going to be sitting in the S3 buckets. Once the code has been retrieved, we're going to actually spin up the container itself. That's going to be, you know, doing the work to actually invoke your code or to actually run the code. We do need to load that code into memory, which is one of the things that are going to happen there. And then the actual important part, running the actual function that you've built here. So those first three steps is what's going to be happening as part of that cold start. And that cold start, the time there can vary quite a bit depending on, you know, the language of choice, amount of code within your functions. There's quite a few various things at play here, which can have quite a massive impact on the performance of your function in terms of, you know, the amount of time it takes before the user gets a response. So if you have a very large cold start time, this can really impact the user, you know, in terms of what they see before, you know, something actually shows up on the screen. Things could appear unresponsive. So that is something that really has to be taken a lot into account when, you know, determining, you know, maybe your language of choice for building a serverless function, and maybe the type of things that you use your serverless function for. When it comes to, if it's anything that's really, you know, really dependent on performance, serverless may not be the best choice here. Now, it's important to mention a little bit about with, you know, serverless, your serverless function. Even though your function is going to be invoked, you know, this cold start is not going to be happening all the time, not for every single function request. When your function is invoked, the container may sort of be available for about, you know, 10 minutes afterwards to serve future requests. And that is to kind of minimize, you know, the amount of cold starts that you might see. So you can kind of think maybe something that is getting invoked all the time and it's constantly under user request. The users may never see that cold start because it's constantly, you know, serving incoming requests. If it is something that doesn't get invoked too often, or at least not often enough, maybe, you know, eventually this cold start is going to happen and users are going to start seeing some of that performance impact there. So that's one thing that's important to know. There is a lot of information here on the internet about cold starts. As I can see here on a website, it's typically mentioning how after this 10 minutes, you know, 10 minutes after your previous invocation, the probability of a cold start happening does increase quite dramatically. So typically that 10 minutes time scale is where, you know, a cold start is almost definitely going to happen the next time a function is invoked. Also here, your language of choice has a really big impact. JavaScript, Python have fairly low, you know, cold start times comparatively, you know, against something like Java. C# here has quite a large cold start time, you know, sometimes even looks like approaching a second or a full second here before the actual function is invoked. So that, as mentioned, can have quite a big impact on your users. So with all that said, what has been my actual experience of developing a serverless application, using that all the way through? I've built a series of projects, particularly with kind of React on the front end and using serverless and Amazon DynamoDB to serve a lot of my users for some of my actual applications. I think in terms of managing cold starts, one of the experiences that I've particularly kind of come up with is it really is a lot easier just kind of going with these, you know, these scripting languages for developing your functions as opposed to using things like Java. When I first started, I did have my backend completely written in Java, and I'd done a lot of things to try and keep those cold starts down when I was seeing them happen. There's the idea that you can invoke your functions in a kind of regular interval, maybe every 5 minutes, every 10 minutes, to try and keep them warm and not experience cold starts when you have an actual request coming through afterwards. The main issue with that is now, I guess, as a developer, now you are, the whole idea of using serverless is to kind of make the whole experience a lot easier and not have to think too much about infrastructure and some of those things around that. Having to actually manage invoking your functions in a certain interval, particularly if you do get a large input of or a large volume of requests coming in, doing this doesn't necessarily guarantee that you won't get a cold start. And the main reason is if you do have a lot of requests coming in, multiple containers will eventually be spun up to handle those requests. So it won't necessarily be one, it will be, a handful of them. It could be quite a large amount of them. So there can be sometimes no way to predict that unless you're constantly yourself hammering all of your functions all the time to kind of preemptively handle any requests without any cold start. So, you're going to experience a cold start every now and again. So the only way you can really try and address that is to keep that cold start as short as possible, and that is with your choice of language. I've had a lot of experience using JavaScript and TypeScript for that, and that seems to keep the cold starts to a reasonable level as opposed to something like Java. It's also worth mentioning all of the libraries that you're using. Don't just kind of import a whole bunch of libraries. Particularly large libraries are going to impact your cold start time. As mentioned, that package code or that package size has a big impact on that cold start because your container has to actually retrieve the code from external storage into the container before it's invoked. So making sure the package size of your functions is quite small is something that is really important. Typically, I think with Java, it's quite heavyweight in terms of libraries and even the code itself, even once compiled down to bytecode. So that really does impact things. Using things such as Python, such as JavaScript, such as TypeScript does really keep that cold start time down, because you are kind of going to experience a cold start eventually. I do think the barrier to entry with serverless is incredibly quick, and it's really great to be able to develop something from scratch really quickly, get it out on the web, have something working, and there's a lot of tools there with serverless to actually help use of that and develop things. There's also monitoring, which is kind of an important thing. There are some tools and there's some things out there. One I've been using a lot is Tundra, and it gives you a very nice breakdown of kind of graphs, how many errors you're getting, how many cold starts. This is actually what Tundra looks like, which gives you a lot of information. You can sort of see your invocations of serverless functions over the last day, the last month, a custom range, and it will give you a nice sort of ability to see how many functions were invoked, what sort of the estimated monthly cost, how long things have taken, the amount of cold starts that's occurred, and you can even go in there and drill down to see individual functions that you've created, how many invocations of them that there are, and sort of which part of your function is taking the longest amount of time. So a good example here is my function is making use of DynamoDB. There's 2 DynamoDB queries, and they've taken a certain amount of time, and this is like the total amount of time that entire function has taken. So it's a really good tool to be able to drill down in your functions and actually see, is there small bits that you can do to improve, and what's taking the longest amount of time. You can also check and look at the errors and see what is the reason why certain errors have been invoked, and if a cold start did happen, it mentions here it has, there's been cases of cold starts, but overall, the function has taken less than 2 seconds. So for what I'm using this for, that's not too bad. But as mentioned, using a lot of these monitoring tools, looking out, the cold starts and your actual use of which particular language, that can have a big impact on some of the cold starts and just the overall performance of your serverless applications. Well, I hope you found all of this informative. As I've mentioned before, if you like these videos and this type of content, please mention in the comments the type of things that you want to see. In the future, I'm going to be delving a little bit more into serverless and doing an actual tutorial to show you how to generate everything from scratch in terms of actually building the application and doing sort of this full stack front to back using serverless. Please hit the like and subscribe button and be on the lookout for future videos.